Hello everyone, I am Vinod Salke working as Assistant Professor in Maharishi Parashurama College of Engineering. Today we will move on to the next part of the network theory subject. In the last lecture we have seen some problems on the KVL and KCL. What is KVL and KCL? KVL is Kirchhoff's voltage law and KCL is Kirchhoff's current law. So KCL and KVL you have you understand that difference between KVL and KCL and how we should use KVL and KCL that we have studied. Now we will move on to the next part, that is circuit reduction techniques. What is circuit reduction technique? Now if in the exam if they are given one circuit, in that circuit you have to solve that circuit and you have to find out the parameter they have asked. Means suppose they can ask voltage, they can ask current, or they can ask any resistance, inductor value, capacitor value. So you have to find out by using reduction of a technique and you have to simplify that circuit. So by which way you can reduce the circuit and you can find out the voltage value, that we have to study in this lecture. So you can see here I have given circuit reduction technique and case first current source in parallel. So I will use here, suppose there will be a current source. So this is current source value is 3 ampere and this current source value is 2 ampere, and suppose this is AB port is given. Okay, so tell me in the chat box the value of the total circuit. I will simplify this circuit, what will be the current source? So suppose A and B, I want to calculate load across A and B and I want to solve this 2 ampere and 3 ampere. How I can solve this 2 ampere and 3 ampere? So you can imagine and you can think about it and you put the answer into the chat box. So what is the answer of 3 parallel 2? So I will write here. Now see the direction of the current sources. Current source direction is upward for both, for 3 ampere current source and 2 ampere current source. Both direction is in upward direction. That's why, and we have to add here, they will add each other. So 3 ampere plus 2 ampere, that is 5 ampere, and this is upward direction. Okay, so that is simplification of the parallel circuit when there will be a current source. Okay, so you can't, if there will be a voltage source, you can't add that because voltage is same into the parallel. Okay, parallelly they are same. In the current source, in the series they are same. Okay, so 3 ampere and then 2 ampere. So this is the circuit of the 3 ampere and 2 ampere. This is a 5 ampere circuit. Now I will use, suppose here I will use current source direction is like this. So what will be the answer? Can you imagine? Just think about it. Think about this structure, 3 ampere and 2 ampere. What will be the value? What will be the direction of the current source? Final current source, or what will be the final value? Okay, so put that value into the chat box. So 3 ampere. Now direction is opposite. So 3 ampere minus 2 ampere is equal to 1 ampere. So 1 ampere direction is upward because this 3 ampere is bigger than the 2 ampere. That's why direction is the bigger one given by the bigger one, that is 3 ampere. So 1 ampere in the current source in the upward direction. So like that we can solve the current source in the parallel. So that is case 1. Now move on to the case 2. Case 2. What is case 2? Suppose voltage source in a series. Voltage source in series. Suppose there will be a voltage here plus minus and here is plus minus. Polarity is same, A and B again. I will say here is a V1 and I have V2. So total voltage. What will be the total voltage across VB? So V is equal to, tell me in the chat box what will be the answer for this figure. So that will be V1 plus V2. Now we can conclude that when voltages are in the series, they have to add. When current sources are in the parallel, they have to add. Okay. So that is the conclusion from these two techniques. Okay. So V1 and V2 plus minus. So V is equal to V1 plus V2. So that's why you can calculate this voltage source in series. Okay. So that is just I will give the example for you, and you have to calculate the final answer for the voltage series. So plus minus 10 volt, minus plus 3 volt, plus minus 6 volt. Now I am giving you 15 seconds and you have to calculate final voltage. So calculate final voltage and tell me into the chat box. I hope you can solve. It's very easy. Okay, so what is what we are doing in the voltage source when we are in the series? We have to add them. Okay, so we have to add them is 10 volt plus 6 volt. Now this polarity is opposite. Okay, so that's why 10 plus 6 minus 3. So 10 plus 6 is 16 minus 3, that is 13 volt. So V is equal to 10 plus 6 minus 3, that is 13 volt. So that is the case when we are using voltage source are in the series. Okay, so we can use current source, voltage source in the same circuit also. So that we will see in the next cases. Okay, so that case number 3. Voltage source in parallel with an element. Voltage source is parallel with any element. Okay, that is the case now. Case number 3. Voltage, when the voltage source are in parallel with any element. So that time we have to solve how to solve that circuit, how to reduce that circuit that we have to study. So I am writing here is a V1. Suppose I will take this V only, and this is the resistance R, and here is the A and B R. So what is the equivalent circuit of this? What is the reduction of this circuit that we have to see? Now that is, you can say voltage source in parallel with any element. Any element means if there will be any voltage source, current source, or any resistor, inductor, and capacitor. Any element can be that. But I am taking only resistor. More complicated circuits we will take in the next when you will understand this concept. That time I will take more complicated circuits. But now I am taking only a resistor. Okay. Suppose resistor is parallel with this voltage. So what will be the final circuit when we are considering voltage in the any element? So that time we have to neglect that resistance when the resistance in parallel with voltage, any voltage source, because this voltage source will dominate on this resistance. That time we have to neglect that resistance. So this any element will be reduced to this only voltage source V, and this A and B. But I am done here. Only I reduce this resistance and only voltage source is available. So there is nothing different, another term available, that resistance only will be a resistance are just eliminated from that equation. Suppose there will be any resistance available here, then we have to keep that resistance. Why? Because it is in series with the voltage source. Okay, so that's why you don't have to reduce that eliminate that resistance. You have to keep it in the circuit, like it should be available here. That we will see the any complicated circuit available. So that is the case number 3. Okay, I am giving you one example. So you solve that example, or parallelly I will also solve that example. Parallelly, you also draw in your notebook. I hope you are sitting with your notebook and you are drawing parallelly with me, so you can solve it with my pace. And question is, find the current through 10 ohm resistance. Question is, find the current through 10 ohm resistance. What is question? Find the current through the 10 ohm resistance. Now what is the actual source reduction technique or simplification technique? When there will be a voltage source, there will be any element in parallel with any voltage source. We have to eliminate that. We have to we have to cross them, or we have to reduce them from your circuit. We have to eliminate. Suppose there will be now how many voltage sources are available here? So here is a 5 ohm resistance. I hope you understand the problem. Now see here, how many voltage sources are available in this circuit? So 1, 2. So 2 voltage sources are available in the circuit. How many current sources are available? 1. How many resistance? 1, 2 and 3. Okay. So these are the elements available into the circuit. So any element parallel across the voltage source, you have to eliminate it. Means you have to eliminate this one, you have to eliminate current source, you have to eliminate this 2 ohm source. Now you will say that this is the voltage source. What about now? See who is bigger one, 5 volt and 1 volt. You have to consider bigger one. So bigger one is 5 volt. So you have to eliminate that. What about this 10 ohm resistance? We should eliminate it or not? No, we don't have to eliminate. Why? This is also parallel to the 5 volt voltage, but why we are not eliminating it? Because in the question, find the current through the 10 ohm resistance. We have to find out the current through the 10 ohm resistance. That's why we can't eliminate that 10 ohm resistance. Your simplified circuit will be, I will eliminate this, and current, that is your final answer. Is that simple? So that is the way you can find out 10 ohm resistance. Okay. So I think you understand this problem with yes. Just put yes into the chat box. Otherwise, I will solve in the next lecture that you will not. If you not understand, I will take that into the next lecture, that question. So just if you are giving me a feedback, yes, I will go with this understanding that you have understand that problem. Next is solve for your own. I hope you will solve it. Find I in the circuit shown. So this is 6 ampere current source. This one is 6 volt voltage source, and we have to find out current through this branch. Here is 2 ohm resistor they have given. 4 ohm, 3 ohm, current I you have to find out. That is 2 ohm. Okay. So I think we have simplified this circuit. And now we have to find out the current through this 4 ohm and 3 ohm. Now you can think that which you have to eliminate from this circuit. Okay. You just think and tell me the answer, or draw this figure and post it on the WhatsApp group or message me on the personal number. Okay. So what is the intention of this figure? You will just draw and take a photo, and I will appreciate if you will do that. Okay. So I will appreciate if anyone giving feedback and if anyone taking efforts. On the basis of that efforts, you will get your terminal. So try this at your own and give me the feedback. Okay. Next part. Case number 4. Current source series with an element. Now we have to see this current source series with an element. So case number 4. In the up till now last lecture we have seen that when the voltage source are in parallel with any other element. Now in this case we have to find out when the current source is in series with the resistance. Okay, so we have to find out now what will be the conclusion, what will happen when current source is in with parallel series with the resistance R. In the I think KCL and KVL time also I have told you that when the current source is in series with any element, we have to reduce that or eliminate that component. Okay, so means when there will be a current source and there will be a resistance, you have to eliminate that. Okay, current source I, A, B. Okay, so current source is available A and B. So A, B current source and this is your simplified circuit now. This is this simplified circuit of, and this is your answer. Okay. Now we will take example and you try to solve with me. Okay. You have to try solve with me so we will understand. Question is find voltage across 1 ohm. 50 volt. Next is plus minus 30 volt. Zero. $15 volt. $10 ampere. 10 ohm. 1 ohm. 1 volt. Okay. So we have to find out voltage across 1 ohm. So this 1 volt we have to find out. So it's looking very difficult circuit, and there is a current source there given as 2 ampere, and we have to find out the voltage across this 1 ohm. How to find out? Okay. So you try. I will give you 30 seconds. You try for it. Imagine what can happen. And this is the case, current source in series with an element. Okay. So that time what you have to eliminate? You have to eliminate resistance and voltage source and other current sources which are small in size with a bigger one. Okay. So compare and which will be the final that diagram. Okay. So see here, how many voltage sources are available in this? 1, 2, 3. Okay, 3 are available. But voltage source doesn't matter for us. How many other elements? Resistance 1, 2. I forgot to write the value. That is 6 ohm. 1, 2, 3, and 4. 4 resistors are available in this circuit. Now, and how many current sources are available? 2 current source, 2 ampere and 10 ampere. Our case is current source in series with an element. So which current source you will keep? Tell me in the chat box which current source you will keep and which you will eliminate it. Which will be? So current source, that is 10 ampere, you will keep, and 2 ampere you will eliminate. Why? Because 2 ampere is small than comparatively 10 ampere. Okay, so 10 ampere current source you will keep, and the direction is upward direction, and other will be reduced. So this circuit will be reduced to. What about this 1 ohm resistance? Will you keep or you will eliminate it? You will keep it. You have to keep it. Why? Because we have to find voltage across 1 ohm resistance. We have to find out voltage across 1 ohm resistance. So you should keep that voltage. Keep that resistance. So this resistance are with this, and this current source you have to calculate that current is 10 ohm. 10 ampere. Current source is given, and here is the 1 ohm. Now apply Ohm's law and tell me V is equal to R. What is I? Current is 10 and resistance is 1 ohm. So 10 into 1, 10 volt. So that is the way you can calculate the 10 volt voltage across this 1 ohm resistance. Okay, so that is the way you can find out the solution for that. Next part. Next, I will give you one example for your homework, and we will stop here and we will see some source transformation into the next lecture, and we will go for that nodal analysis and mesh analysis, Thevenin and Norton theorem. Okay. I hope you are doing your homework regularly. Find current I from circuit shown. So draw the circuit. Plus, minus. This current source is given as 5 ampere. This current we have to find out. This 3 ohm resistance, and here is the 4 ohm resistance. Okay. Now we have to find out the current I through the 3 ohm resistance. So what you will keep? You have to keep this 3 ohm resistance, and other we have to keep that is 5 ampere current, because current source in series with an element. So that's why those elements are in series with the current source, that we have to eliminate. This one. So it is in series. Okay, it is in series. That's why we have to eliminate that voltage source and this resistance, so that we have to find out in this circuit it will remain only what this current and this resistance. So you try to solve. Almost I told you how to solve that problem. You just solve and tell me what will be the answer. You can message me, or you can put into the chat box. Okay. So we'll stop here for today's lecture, and for the next lecture, as I said, we will go for the next topic, that is source transformation. That is very important. Source transformation is very useful topic, and it will be simplify the circuit by the way which you want. Okay. So thank you for today.